I'm Peng from Shanghai American School, Pudong. Today I'm going to be sharing my invention, NetGenius AI, a real-time interactive tennis ball survey machine based on machine vision and mathematic model. Tennis has always been my top hobby when I was a little kid in elementary school. However, I often found a common headache among all tennis players with the need to make effort to find partners or hire coaches to play with them, which is really inconvenient and expensive. Thus, I really want to elevate this experience of playing tennis and its joy by revolutionizing how traditional tennis ball serving machines work. The current state of tennis ball serving machine only offers simple serving functions that can only fulfill training purposes, like stationary serving, preset serving points, and a large size which is hard to carry it around. There is a new need for a new class of robot that can solve these issues by providing users real-time interaction, competitive and diverse experience, and a limited size. Thus, these aspects lead to my three main aspects of my engineering goal: engineering, mathematics, and programming. I designed a set of mechanical structures that combines a machine vision module and a mathematical model to realize real-time interaction. And I also included a wearable device that can externally communicate with this robot to measure physical condition of users. Here is a methodology flowchart of my procedures, from background and market research to building prototypes, and lastly, data analysis for my final product. My work is mainly separated into two parts: software and hardware. My software system is built with programming following the cycle of first activating the machine as camera, capturing human movement, calculating returning direction, speed, and placement. My hardware system follows a repeated cycle of designing blueprints to 3D modeling through software like CAD, and lastly, print them out and refine each iteration. The most important part of my prototype is the mathematical model I designed. It can really help to achieve my goal of making real-time interaction with the user. It basically sees the half of the tennis score as a coordinate matrix, where each point on the matrix refers to each point on the court. And when the camera identifies human position on the court, it sends out parameters and in-text in the forms of coordinate points to the machine, and thus it will substitute these numbers into two mathematical equations to calculate returning placement and propulsion power. Overall, my machine underwent 4 main iterations, from a wooden chassis to a final product that is completely made up of 3D printed materials, more stabilized and compacted, and it has even applied for a patent. As I finalized and polished it during my later stage, I managed to conduct different kinds of experiments to testify its accuracy and usability. Through machine learning of the software YOLO of 22,402 images, it can accurately identify and frame out human in photos for 91%. And during other experiments, as you can see from chart 1, it refers to an experiment that I did with my friction wheel, exploring the most effective material to be used, which is silica gel. And later, during encore simulation test, as you can see from chart 2, it refers to that my machine can accurately send balls to points in front courts for 83% and backcourt for 88%. For now, I'm very proud that my machine can fulfill these needs and meet my engineering goals, as it can provide a real-time interactive, competitive, and diverse experience at a minimized size. Some issues that I found during encore simulation tests is still the inefficiency of friction wheel generation of power. However, I quickly fixed this as I explored the most effective material to be used. And later, I'll finish up my invention with my wearable device through the chip ESP32 and add more star player playing strategies into my machine's database to make it imitate like real human players better. In conclusion, my machine succeeds to apply AI technologies into the need of fulfilling multidimensional interaction between robot and user. And as you can see from this SWOT chart, my machine remains to be the smartest and most easiest and convenient to be used. Most importantly, it refers and provides insights and reference to future application of AI in small ball or net sports fields. Thank you.